So hi everyone. So in this video, I will explain about the half header. Okay. So mainly, we will make the two part for this. In the first part, I will discuss. I will cover about half header, truth table, Boolean equation, and what are the circuitry. So circuit is important for half header. Okay, and the what are the block diagram representation. And in the second part, this is also important. How can we design the half header using only NAND gate, yeah, NOR gate, and if you want to design the OR gate, how many half header is needed? Okay, so let's we start this video, and in this video we'll discuss this part. Okay, so firstly, what are the meaning of the half header? Okay, so what is half header? So mainly it is used to add two one bit number. Okay, mainly it is used to add the two one bit number. Suppose we have a and b. A is one bit and b is one bit. So one that is the two bit. So for two bit there are the four combination is there. Okay, but before going on the truth table, here I will discuss. Do you know about the binary addition? Binary addition means, suppose, because here we will need the binary 0 plus 1, sorry, 0 plus 0, 0 plus 1, and 1 plus 0, and 1 plus 1. Okay, just this thing I am explaining here. So do you know this thing? Okay, give me one minute. Sorry. Yeah. So if you add the two binary number na, then there are the two things is there. One is the sum and another is the carry. Okay, they are the two things. If you add 0 plus 0, sum is 0, but no carry means the 0. Okay, 0 plus 1, sum is 1, 0 plus 1, sum is 1, and what is the carry? If carry is no, then 0 carry. 1 plus 0, sum is 1, carry is 0. But so this is the point. Okay, these three is same. Like any base system, if you add the two number, that is 0 plus 0 0, 0 plus 1 1, 1 plus 0 1. In three case, carry is 0. But if you add 1 plus 1, the sum is 0 and carry is 1. Okay, so this thing you should remember. So mainly here I explain, because of that the half header it is used to add the two one bit number. Okay, if a and b are the two one bit numbers, so there are the four combinations. In the next slide I will explain. So but before going to this, here I explain about the binary addition. Okay, binary addition. If you want to the three bit number, I will discuss in the full header. And this is the base. The base rule. On the basis of that, you can add any binary number. Okay, 0 plus 0, 0 plus 1, 1 plus 0. There is no carry. But if you add 1 plus 1, sum is 0 and carry is 1. Okay, I hope you understand. So in the first part about half header I covered. Then now we will make the truth table, Boolean equation, and circuit and block diagram. Okay. See, how can you make how can you make the the truth table? The TT. Okay, TT stands for the truth table. Okay. So assume we assume the two bit number, that is the A and B. Okay, and this is for sum, and for sum I am writing S. Okay, and this is carry. So for carry I am writing C out. Okay, see here. So actually I explained the half header it is used to add the two one bit number. A and B is the this is one bit. So total two bit. If you have a two bit, means there are the four combination. For two bit, for two bit we will have a four combination. Okay, four combination, you know this thing. So four combination, 0 0, 0 1, 1 0, and 1 1. Okay, so this TT table is important, and the interview sometimes will ask like that. Write down the truth table of the half header. Okay, so 0 plus 0, sum is 0, carry is 0. 0 plus 1, sum is 1, carry is 0. 1 plus 0, Sum is 1, carry is 0. 1 plus 1, I am writing in another color. Okay. 1 plus 1, sum is 0, carry 1. Okay. So this is the thing. How can we write the expression for sum and so carry on? Here I am writing the SOP expression, sum of product. I hope you know this thing, the meaning of that. Okay. So here you can see what are the expression of the sum. Sum is so for 0 0 and 1 1 output is 0, but for 0 1 and 1 0 output is 1. So if you know the truth table of the XOR gate, so this is the XOR gate. XOR gate means this is the odd one detector. So this is the A XOR B. Sum expression is A XOR B. Okay. And for carry you know, so this is the very simple. If any number of input is 0, output will be 0, output will be 1. If and only if both the input is 1. So this is the AND gate. So this is the Boolean expression of the half adder. So this is the AND gate, and this is the XOR gate. I hope you understand this thing. Okay. So I covered the truth table, Boolean expression, and the TT. Okay. And now I will make here the circuit diagram. How can you make? So this is the circuit is very. So if you want to design the half header, how many gate is needed? So only two gate. Two gate means one is XOR gate, and one is AND gate. Okay. Here I am making the circuit. Circuit is very simple. This stands for the AND gate, and this stands for the XOR gate. Okay, I hope you understand. This is a very simple. So this is the two input A and B. This is the two input. Okay. So it stands for the carry, that is the C out. Here you can write the C out if you have a dot like the C. No dot means this is the C out, that is the AB, and S for sum. Sum expression is A XOR B. Okay. So this is the circuit. So this is the circuit of. So this is the circuit of the half header. So this is the half header circuit. How can you represent in the block diagram? So this is the very simple. I am writing in the next slide. Okay. How can we represent in the block diagram? Just make the one block. In the I mean in the future, if you become the mainly the digital design engineer, then you will understand the meaning of the block. Okay. So inside this block, we have a half header circuitry. Okay. And here we have a two input A and B, and here is the two output, one for C out is AB, and sum is AFW. HA stands for half header. Okay. So this is the block diagram. Okay. So every time if I need anything, if we will need the half header, then here we will insert the half header block. Okay. This half header block, I mean inside the half header, if you go inside half header, then inside the half header there is a circuit, one XOR gate and one AND gate. Okay. I hope you understand this thing. So in the next part, I will explain how can we in the next part I will explain how can we design the half header, so using only NAND gate, yeah, NOR gate. Okay, this thing. So in this part I explain this is important. So equation and circuit is important for this part. Sometimes in the interview, interviewer will ask, can you write the truth table and Boolean equation of the half header? Okay, and circuit also. And the second part is most important. Sometimes also will ask like that, can you design the half header using NAND, yeah, NOR? 9, yeah, no. Neither is easy, nor is something is difficult. Okay, I will explain in the next part. Thank you. Thank you for this part. In the next part, we'll meet. Okay, bye.